Okay, hello students. Today we will start with the new topic, that is our WAN design, right? How to do a WAN design, what are the different considerations you need to take care with this particular WAN design, right? But before that, we will see what we have covered in our last session, right? So we have discussed about this 4.1, that is enterprise edge WAN technologies, right? So what are their different WANs are there? What do you mean by the WAN? There are different goals and objectives of each of the WAN, right? That we have studied. Then a different WAN interconnections with respect to your enterprise network design, that also we have seen, right? And after that we are moved towards our traditional WAN technology, right? That is leased line, packet switch network, packet switch, and the cell switch network, right? And then we have discussed about how these particular traditional WAN technologies can be compared with respect to your OSI layer model, right? So you know already the layer 1, that physical layer, and the layer 2 data link layer are taken apart into this, right? Then we have discussed about the different topologies of your packet switch network, right? So star topology, fully mesh topology, and the partial mesh topology, right? And out of that, this particular partial mesh topology is will the best suited for this particular packet switch network, if you consider this particular topology, right? And after that we have discussed among there are various types of the WAN transport technologies, right? So from that each of this particular transport technology we have seen in our last session, right? And after that we have also discussed with respect to their pricing and the contract considerations, right? So how it can be useful, right? So with respect to that also we have discussed, right? So these are the points we have already discussed in our last session, right? So we are going to see today the 4.2, that is your WAN design and the WAN what are the different WAN technologies we have, right? So in this, if you see, we will start with how the planning and designing can be take place, right? So with respect to the PPI OO model, right? So whatever we have studied, right? So it will be useful for the network design model, right? So how it can be helpful for in this particular WAN design also, right? So that also we will see. Then there are different parameters for the application requirement with respect to the WAN design is concerned, right? So that also we will see, for example, the response time and the downtime and all that things, right? So that also we will see. Then how the technical requirement can be fulfilled, right? So I will show you one graph, right? Through that you will easily understood that how this particular maximum of traffic can be worked with respect to the response time, right? And how this particular bandwidth also is be satisfying this particular technical requirement, right? So with respect to the different types of the wired or wireless media, right? How this particular bandwidth can be utilized or bandwidth can be used, right? So that will also we will discuss. And then we will see how this particular cost effectiveness of this particular WAN ownership, right? That means whatever the setup we have with respect to the WAN, right? So how you are going to use that particular setup, or how you are going to set up that as an cost effectively, right? So that also we will see. Then how to optimize the bandwidth, right, in your WAN network, right? So that also we will see. Then queuing to improve the link utilization, right? So whatever the link in your organization, what is the percentage in which that particular link utilization will be take place, right? And how to improve that particular link utilization with the help of queuing, right? So there are some few techniques of queuing with respect to that we will improve our link utilization, right? And lastly, how to avoid conjunction in between the links and in between the communication, right? So that also we are going to discuss. Okay, then we will move towards our WAN technologies, right? So there are 4 types of the WAN technologies I have listed here, right? So first one is the remote access, right? So through remote access, how you are going to use that particular WAN technology, right? Then another one is nothing but the 15 virtual private network is there, right? Then the third one is the you can create your WAN backup, right, for later use, or for any emergency kind of the thing, right. And then the internet as a backup of WAN, right. So how you are going to use the internet in terms of this WAN backup part, right. So all these are nothing but the today's content, right. So we will start with the lecture, right. So the first point, the planning and the designing, if you go with this, right. So but before that, I just remind you that PPDIOO model, right, whatever we have studied in our previously in previous chapters, right. So that is nothing but one of the network design methodology, right. So that is a plan, D for design, I for implement, O for operate, and O for again optimize, right. So these methodology, when we are used, right. So we have discussed among some how the network and customer requirements can be analyzed, right. How the characterizing this particular existing network and the different sides of that, right. And then again how the designing of the network topology, and how to provide the solution for that particular network problem, right. So all these things we have already discussed, right. So based on that, because if you see, the WAN is also nothing but one kind of the network, right. And that also you need to plan, you need to design, right. And for that also, this particular PPDIOO model, you can take it as a base, right. And from that particular base, you need to start for planning and designing this particular WAN networks, right. So if you see, in this particular WAN network also having some of the trade-offs, right. So for example, if you see the first one, right. So application aspect, the requirement driven by the performance analysis, right. So whatever the application you are going to use for that particular WAN, right. So you need to also identify what are the different requirements for that particular application, right. So that you need to think on that particular performance analysis line, right. So how you are going to analyze the performance of that particular application, right, unless and until you are not finding any requirements of that particular applications, right. Then the next aspect is the technical aspect, right, of that particular requirement, dealing with geographic regulation and the effectiveness of the selected technology, right. So whatever the technology, so we have already discussed, there are numerous technologies of WAN, right, or WAN transport technologies also we have discussed in our last session, right. So how you are going to select that particular transport technology, right, and how the requirements of that particular transport technology will be fulfilled in for your organization, right. That is also one of the trade-off, we can call it as, right. Then the third one is the cost aspect of the requirement, right. So I have also mentioned in our last session, right. So the last point is regarding your cost only, right. So you need to check the cost aspect for the requirement also, right. So whatever the equipment and whatever the what leased media, if you are using any communication channel, right, then you need to see, or you need to check the cost aspect of that particular requirements as well, right. So in order to while planning and designing, right, so all these three aspects you need to keep in mind, and accordingly you need to design that particular thing. Because if you see, whatever the network design you are going to do, right, so you need to must think upon the what are the different future technologies you are going to use for your network designing. Because if you see, nowadays adaptation of these new technologies will become the mandatory, because if you not adopt it, right, so your network maybe failed in some time, in some duration, right. Then there will be no any component, then there will be no any equipment that will be available for your own old technologies, right. And it will be, you need to at that time you need to upgrade it with the only a new setup, right. That will be cost very much more, right. So that's why you need to think upon firstly, for example, if I wanted to give, then nowadays all are shifted to the VoIP technologies, right. So that is nothing but the voice over internet protocol technology, right. So in that particular technology, if you not consider it, right, for the implementation and the design part, right. So so if it will be not it will be harmful for you only, right? Because after some time whatever you are using, right, so that will be in that is nothing but your trade off, right? It will be getting old, right? And you are not going to get all the beneficial, right? So whatever the required for this particular van design, right? Then if you move towards this particular application requirement for your van design, right? So in this application requirement, if you see in this particular table I have shown you, right? So there are some requirements over here. So like this we have also seen for application requirement for our campus design as well, right? So in here in this application requirement for van design, if you see the requirement, the response time, the throughput, the packet loss tolerance, and the downtime and all that things, we have compare it with this particular data file transfer, data interactive application, and real-time video, right? So how these particular requirements can be fulfilled or can be used in this particular technologies, right? So if you consider the response time, right, so it is nothing but whenever the user accept this particular response times, right, to up to some limit, right? And the point where the user satisfaction will declines, right? And application for which whatever the response will getting from that particular application, right, or response from that particular application, right? So we will be considering it as a critical, right? So for example, if you see the online services or online purchase, right, or for example the POS machines if you are going to use, right? So point of sale machines, right? So these are nothing but one of the examples. So where you these are the some critical applications, right? And from that you need to require a fast response time, right? So so if you see the response time with respect to the data file transfer, right, so it may be reasonable. Data interactive application, it must be within a second, right? The real time voice also it may have some delay, right? And the real time it is also having some minimum delay with respect to the critical application if I am talking about, right? Then if you consider the throughput, right, then what is the application you are going to use for your organization, right? So obviously the traffic whatever is there for that particular application will be will be large enough, right? And whatever the throughput we are going to use, right, so it will be with respect to the end-to-end connections, right? So it will be typically involve all the particular file transfer activities, right? So whenever it will be used in this particular file transfer activities, right, so it will usually have a low response time requirement, right? And it can be, you can also schedule at the time when the response time is sensitive, whenever the traffic is low, right? So at that time also you can schedule that particular thing, right? For example, if I want to give, then the time based access list can be used in this case, in this particular case, right? So for example, if you see for the 15 minutes someone is giving you the access for that particular application, right? Then at the time the throughput you need to measure, that will be some critical part, right? And you need to check all the response time requirements with respect to that also, right? Then the third one is your packet loss tolerance, if you see, right? So for example this particular in this particular packet loss, right? So whatever the it will be improve all the transmission time, right? So forever the given amount of transmitted data, right? So it will be nothing but your QoS parameter, right? So for example your sender is one of the important packets to the receiver, rest, and receiver is not going to get it, that, right? So in the middle of the transmission it will be get lost, right? So what you need to do is you need to just because you are not getting that particular data, right? You are not getting that particular packets, right? So there will be an one packet loss will be there, right? So in terms of the percentage you need to calculate all the whatever the packet loss will be there in the whole communication, right? And you need to indicate that with respect to all these requirements, right? Then the next one is your downtime, right? or we can call it as an reliability, right? Also because if you know the reliability, if I am talking about, right, so it will be in terms of all the applications or all the services, right? For example, if you see the reliability is a important case when I am talking about the financial services, I am about the security services, if I am talking about some emergency, some police, some military operations, if I am talking about, right? So in that, you need to require the 100% uptime, right, for that particular all the critical applications, right? And for that you must have some high level of hardware and topological redundancies for your framework or your infrastructure, right? And so that this will be lower the downtime for that particular critical applications, right? And will be efficiently used. And obviously you need to also determine the cost for that particular downtime also, right? So where if any application which having the critical application, and you are that particular application is down for example for 1 hour, right, then you also required to check what is the they will hamper the cost for you, for your organization, right? So with respect to that also you need to think upon this particular WAN design, right? Then if you see the technical requirements, right, so obviously the goal for any kind of the WAN design, right, it should be optimized or the link performance, right? So in terms of link performance, in terms of you need to calculate for example the response time, you can use the link utilization, you can use the whatever the you are offering the traffic to that particular WAN designing, right? So to optimize link performance, the designer should match up with or should balance with the end user requirements and whatever the network manager requirements are there, right? And depending upon that, they can be set up for example depending upon the manager's goal, they can be set up or they can be maximize the link utilization, right? And also they can be gives as a per user requirement or per client requirement, right? So depending upon the managers and the users response or requirements, this particular technical requirement can be fulfilled, right? So if you for if you see in this first diagram, right, so the maximum offer traffic I'm going to calculate here, right? So if you see, sorry, so if you see the response time and the link utilization, right, so I have response time one graph is there, and for the link utilization I have one graph over here, right? So response time, if you see, it will be increases with the offer traffic, right, until it reaches an unacceptable point for the end users, right? And similarly if you see on the link utilization, right, it will also increases while the offer the traffic, but at the point that the link becomes saturated, right, and it will be become decreases, right? So if you see whenever it will be the designer goal is to determine the maximum offer traffic, right, which will be acceptable to both end user as well as for the network manager, right? So in this way you can determine the traffic, right? And for example if you see whatever the planning if you are going to take for the additional WAN capacity, right, then you should think upon that whatever the link utilization is there for your organization is, right? So it will at least it will be as a 50%, right? And whatever the additional bandwidth you are going to purchase, right, so it should be utilization of that, it must be a 60% at least, right? Because if you see if the link utilization is the 75%, right, then it will be very much critical part or for increasing that capacity for that particular WAN design, right? And it will be also ultimate the cost of that particular is increases also, right? So this all the point you need to take in mind. So in this particular thing, the response time and the link utilization will be very crucial thing for this particular technical requirement of WAN is concerned, right? Then if you see the second technical requirement, that is nothing but the bandwidth, right? So obviously for qualitative, if you wanted to send a packet, or if you wanted to get a better result, right? So obviously the bandwidth will be a crucial thing for that, right? So if you for I want to give you one example, right? For example, if you wanted to download a photograph, right, that is will be taking as 1 second, right, which will be taking more bandwidth, right, with if you compare that the downloading a page of text in 1 second, right? Because if you have any, for example, the large sound files, the computer programs, the animated videos and all that things, right? So it will obviously takes a more bandwidth, right, as compared to the text file and all that things, right? So with respect to that also, you need to think, you whatever the WAN connections you are going to design, right? In that, the proper sufficient bandwidth will be there or not, right? That also you need to keep in mind, right? So if you see in this particular bandwidth table also, right, so I have given here some WAN media type, right? So we have already discussed all these WAN media, right? The copper cable, fiber optic cable, coaxial cable, and this particular wireless, right? That is nothing, the WAN wireless, right? So in that also, depending upon the how many mbps is there, right? So on that particular thing, which type of the technology or which type of the media type you are going to use, right? So it is already given here. Right? And with respect to that, you need to think on which type of the bandwidth you will be required for your kind of the organization, right? And by doing this also, you need to also think upon that the in what circumstances, or in if future expansion you wanted to do, right? So and how this particular WAN media can support to your organization, right? So that also you need to keep in mind. Okay, then we will see the evaluating the cost effectiveness of WAN ownership, right? So if you see in this WAN environment, right, so these, for example, is already having the fixed cost, right? So it will be not change in this, in that particular WAN designing, right? So for example, if you see the equipment purchases such as modems, the channel services, data services units, or the router interfaces, right? So these are the equipments, whatever the hardware components are there, right? That are fixed cost, right, and that you need to be purchase, right? Then the circuit and service provisioning, that also you need to keep in mind, whatever the hardware you are going to use, right? So on that particular part, you need to also provide the service provisioning over there, right? And the third one is the network management tools, right? And platforms recurring costs, which include the monthly circuit fee from the provider, and WAN support and maintenance, including any network in any network management personnel, right? So for example, if you see any kind of the WAN design, right? So how you come to know the performance of your particular WAN design, right? So with the help of only the network management tool, right? So with the help of network management tool, you can manage, you can monitor all this kind of the all this kind of the equipments, whether it will be performing in a well manner or not, whether it will be having some great throughput or not, right? And all that things, right? So and also for troubleshooting, it will be helpful for you, right? So it will be helpful for you for support and maintenance of that particular WAN, right? So and all for all this part, right? So this particular service provider is getting charged from you, right? So on the monthly basis, on the yearly basis, and whatever the terms and conditions for that particular service provider, right? So depending upon that, it be handling all these things, right? So these are the costs which are the fixed cost, right? So you can't change all these things, right? So because it will the necessary part with respect to that particular WAN design, right? Then if you see there are a number of three categories with respect to the WAN links, right? So private link is there, lease link in there, and the shares link is there, right? So what do you mean by the private, right? So whatever the private WAN you are going to use, right? So it will be uses the private transmission system, right, to connect all the LANs and all that things, right? So owner of that particular private WAN, right, he or she will must buy that particular WAN and configure and maintain maintain that physical layer connectivity, right? So physical layer connectivity, when I am talking, then in terms of your type of the wired media or wireless media, right? For example, the copper, fiber, wireless or coaxial cable, right? So in that way you need maintain all this physical layer connectivity, right? And whatever the terminal equipments you are going to use, right? So to that particular cable, right? So that that locations, that things also you need to be buy, or you need to configure and maintain by your own, right? So that's why it is nothing but the private one, right? And if you see the leased link, right? So leased WAN can be used dedicated bandwidth, right, from the certain carrier company, right, with either a private one, or it can be also for leased terminal equipment, right? So the provider, the service provider, or that particular lease line provider, lease link provider, provision that the circuit and provide all the maintenance part, right? So you are not need to give any kind of the maintenance over there, right? So you just need to get the maintenance service from that particular leased provider company, right? And you need to pay to that particular company for all this part, right? This is nothing but the leased one, right? And the third one is the shared one, right? So shared WAN, which will be the sharing all the physical resources, right, with the many users. For example, the carriers which will be offer variety of the circuit or packet switching transport network, right? For example, we have already seen this transport WAN, right? The MPLS, the frame relay, right, and all that things. So this particular provider which provision all the circuits and provide maintenance also, right? So for example, the linking LANs, or or WAN media, or the devices whatever used for that particular WAN designing, right? Then the transmission quality also it can be checked by that particular provider, right? So and in terms of, if you are talking about the performance and the security, right, and all this part will be checked by that particular service provider, that WAN design provider itself, right? So this is nothing but the three types where the WAN links can be categorized: the private one, leased one, and the shared one, right? Then we will see how the bandwidth will be optimized in a WAN, right? So there are three way are there in from which we can optimize the bandwidth from the WAN, right? So first of all, what you need to do for the for that, right? So for example, you can use the data compression, you can use the bandwidth combination, you can tuning window size for that particular packet, right? And you can also do the congestion management, right? So it having some queuing and scheduling part, right? So that the congestion can be avoided, right? And the traffic can be shaped, and some policies can be made over there. So by this way, this particular optimizing bandwidth can be take place, right? So if you consider this particular data compression, right, so in this compression you already know, right? So which will be more efficient use of the available WAN bandwidth, right? So which is having some limited, and maybe sometimes it will goes into the bottleneck, right? So compression which we are going to use for bandwidth optimization, right? So having high throughput, right? Because it's just squeezes that particular packet size, right? And therefore it increases the amount of data that can be sent via that particular transmission resources, whatever you are going to use, and within the time period, right? So that's why this compression can be the entire packet, right? Or compression can be you can compress the header part only, or you can compress the payload only, right? And depending upon how you are going to compress and what you are going to compress, right? So depending upon that, then that WAN bandwidth can be optimized in this particular thing, right? So for example, if I wanted to give, then the frame relay payload compression will be there, then X.25 protocol payload compression will be there, right? Then all these are nothing but some of the examples over there by which you are going to compress all these things, right? Then the second one is your bandwidth combination, right? So for that, the PPP is commonly used for establishing a direct connection between the two devices, right? So peer to peer, right? So it is nothing but the we can use for the synchronous and asynchronous circuit also, right? So by using some certain serial cable or certain phone lines or some certain trunk lines, right? The cellular phone, you can use some radio links, you can use some fiber optic links, right? So by using all these things, what you need to do is you need to encapsulate that particular thing, and then you need to send it over the communication channel, right? And after that, this will be we can going to use, or we can going to optimize, right? So by which this is nothing but the bandwidth combination, if you are talking about, right? Then the third one is you need to tune that window size, right? So it is very much important when we are going to achieve high throughput whenever on a particular WAN link, right? Then this particular acknowledgement procedure, that will be confirmed when the correct delivery is there or not, right? Of that particular data at the receiver side. Okay, and this particular acknowledgement procedure can be implemented at any kind of the protocol, right? And because it can be happen, it can be take place as hop by hop acknowledgement, right? And end to end acknowledgement also can be possible with the help of some TCP and all that thing, right? So you can tune that particular TCP windows size, right? And then the sender must stop that particular send, and receiver does not send and any kind of the acknowledgement, right? So this might be unacceptable in WAN links, right? But by which you can do the bandwidth optimization also, right? So this is also one way. Okay, then we see what are the queuing we are using, right? So scheduling and queuing we are going to use for improving the link utilization, right? So you already know, to improve link utilization, right? This particular Cisco, right, which already develop one QoS techniques, right, to avoid all this this particular conjunction, and to it will be provide the very much good QoS mechanism to all the critical applications, right? So for that they are just doing all this queuing and all that things, right? So if you see, there are two types over here, the hardware queuing and the software queuing, right? So hardware queuing uses the FIFO strategy, right? First in first out strategy, right? So whichever is necessary for the interface drivers to transmit package one by one, right? And the hardware queue is sometimes also we can call as an transmit queue, right? Because it just gives whatever will be required to that particular interface to transfer from one to another, right? So that's why it is nothing but the hardware queue or transmit queue, we can call it as. Then the software queue, which will be schedules the packet into the hardware queue, right, based on the QoS requirement, right? So whatever the requirement for the QoS, right? So depending upon that, this particular software queue will schedule packets into that particular hardware queue, right? And so for software queue, there are some types of the queuing are there, right? So for example, this WF right? That is nothing but your weighted fair queuing, we can call it as, right? Weighted fair queuing. This PQ is nothing but for your priority queuing, right? Then the this particular CQ is nothing but your the custom queuing. Then WFQ is nothing but your what we can call class based weighted class based WFQ or class based weighted fair queuing, we can call it as. And for LLQ, we can call it as a low latency queuing, right? So all these are nothing but the methods or two types for the software queuing, right? It will be used for your improving link utilization, right? So we will see one by one how it can be happen how it can be improve the link utilization, right? So if you see in WFQ, right, so it will be it will be handle all the problems, right, in the queuing schemes, right, and it will be also on the FIFO basis, right, the first in first out basis, right. So it will be assess all the size of the each messages. It ensure all the high volume senders, whoever going to send all these particular messages, right. And also he will it will be send the senders into out of the queue if it is an low volume, right. So in this way it can be check all the volumes whichever be coming to that particular traffic, right, and whatever whoever having the low volume, it will be just send out of the queue, and it just imports first of all the volume which having some high volumes, right. So high volume senders it can be uses, right. So if WAN links are constantly congested, right, so either the network requires a greater bandwidth, right, or the compression should be used, right. So in that part this particular WFQ can be enabled, right, and by default it will be having a low speed serial interface, right, on that particular Cisco routers if I am talking about, right. So it will be very easy to configure, right, and it will be gives the traffic which having sometimes of the priority, right, and it will uses accordingly, right. Then this is nothing but the WFQ. Then the PQ, priority queue, if you use, right, so it is nothing but the sensitive, and if you use any mission critical protocols, right, so this particular priority queue will be work, right, in that case. So if you have some high priority, medium priority, normal priority, low priority, right, so depending upon the priority to priority it can be handle all the queuing, right. So if you see in this particular diagram also, right, and the high priority queue is always emptied before the low priority queues are served, right. So whatever the traffic can be assigned the various queue based on this particular protocol or port number or other any criteria, right. So you should recommend the higher priority queue first, right, and that should be emptied first, then the lower priority, then the lower priority, and then the lower priority, right. Likewise you need to empty that particular priority in that particular priority queue, right. Then sorry, yes, then there is next one is the CQ, right. So this particular CQ is nothing but the custom queuing, right. So in that custom queuing what you need to do is the CQ in custom queue there is an something different approach other than that particular prioritizing traffic, right. So like priority queue, right, what it can happen, the traffic can be assigned to various queue based protocol here, right, or port number or any other criteria, right, and this particular custom queue will handle queue in a round robin fashion, right. So whatever it will be giving chance to each and every traffic, right, one by one, and some of the process or some of the requests it will be giving to the each and every queuing mechanism, right, and after that it will be used as an just like an priority queue, right. So this is also a very much powerful for this particular mission critical applications, right. Then if you see the CBWFQ, which will be allows you to define traffic class, right, and it will be assigned the characteristics for it. For example, if you see if you designate the minimum bandwidth delivered, right, which having some the class conjunction, right, then at that time that particular CBFWQ will be used to extend the standard of WFQ, right. So WFQ we already see on that it will be gives an extended support, right, and user defined traffic classes it will be provided, right. So that's why we can call this as it is nothing but your class based WFQ, that is nothing but the class based weighted fair queuing, right. And the last one we will having an LLQ, that is your low latency queuing, right. So in that we will be having this priority queue, whatever we have discussed in the PQ, and this particular CBWFQ, right. So it is nothing but the combination of this particular two method or these queuing strategies, right. So on the basis of that it will be mixed in nature, right? So hybrid we can call it as, right? So it will be combined this PQ and CBWFQ for optimizing the bandwidth, right? Or improving the queuing for that particular link utilization, right? Then we have this particular conjunction avoidance, right? So these techniques, if you see, it will be uses for or the monitoring the network and the traffic loads, right? So whenever if you are going to monitor this particular network traffic, right, and if you are using that particular conjunction, which can be anticipated and avoided before it becomes problematic, right? Because that is the motto for your monitoring the any kind of the network traffic, right? So whenever the network traffic you are monitoring, right, so at that time you need to check for that particular what are the different access rate are there, right? So is any different traffic mechanism you are going to use or not, right? So if any different characteristics can be there, which will be useful for rating that particular traffic, right? Or is there any bits in the IP packets header which will be useful for that, right? So depending upon that, if you see any enterprise policy management, right? So this particular traffic which we are generated, right? So that can be monitored on the timely basis, right? Because if the traffic is generated more, right, so then sometimes it may happen that it will be collapse your services, your QoS parameters, or sometimes it may happen that if it is maximum than your the threshold, right, then you need to check for its or if any bottlenecks can be there, right? Because of the speed may be mismatched, right? Or if that particular traffic shaping may element that particular bottleneck situation by that particular back traffic volume which will be you can encounter at the source end, right? So depending upon that, you always see the rate of the traffic, right? And depending upon that, you can decide with the how the you can be avoid that with the help of some applying some monitoring on the basis of that, right? So so that is the thing over the congestion avoidance, if you see, right? And then we will see about this particular remote access design. So already you know that in different kind of the WAN technologies, if you're talking about, right, then the then it in that remote access will be there, then the VPNs will be there, that is the virtual private network, then WAN backup will be there, and also we will see how the internet as a backup in that particular thing we are going to use, right? So if you see in the remote access network design, right, so nowadays you know that the remote access network for the teleworkers, if you are talking about the work from home, if you are talking about, right, so traveling employees, if you are talking about, right, so you need to choose technology in such a way that whatever the data link or the network layer connection if you are going to use, right, now if you are analyzing some of the application requirement, right, if you are analyzing some of the service provider offering what they are going to offer you, right, and depending upon that you need to select remote access technologies, right? So there are some requirements over this particular remote access network technology if you concern, right? For example, the data link layer WAN technologies from this particular remote side to the enterprise edge network investment also you need to see, right? The operating cost of that particular are also the main issues over here, right? So all these things you need to keep in mind while selecting the remote access technology, right? Then also you need to think upon this low to medium volume data file transfer or this particular interactive traffic, right? How it can be maintained, right? Or how it can be will be used in that particular remote access, right? And then the increasing need to support voice services, right? So obviously then if you are talking about the remote access, right, so there will be need for this voice services always nowadays, right? So depending upon that your technology must be enabled, right? And for that this already we have seen in our enterprise edge network, right? So one of the functional area we have seen in as a enterprise network, right? So in that also this remote access we have seen, okay? So that also you need to keep in mind. Then we will see the VPN design, that is the virtual private network design, right? So the infrastructure which we are going to use, right? It can be your internet, it can be your IP infrastructure, right? Or it can be your any WAN infrastructure, right? So for example, if you see the frame relay network or an ATM, asynchronous time, that and WAN, right? So these are nothing but some of the infrastructure on which you can design your VPN, that is virtual private network, right? So there are some applications over VPNs, right? So for example, if you see, the access VPN is there, internet VPN is there, and external VPN is there, right? So if you consider this access VPN, right, so which will be provide access to the all corporate intranet, right? Or you can also gives access to the corporate extranet also, right? Which will be over a shared infrastructure, right? And have some different kind of the policies of your private network, right? For example, the remote access connectivity through dial-up, they will provide your ISDN, they will use some DSL transport technology, wireless technology, some cable technology, right? So whatever the transport technology we are already seen, right? So out of that, they can use any kind of the thing for their remote access connectivity in that private network part, right? And after that, they will allow or to access this particular VPN architecture to by using some network access server, that is we can call it as an NAS, right? And through that client initiated that particular VPN, and whether the user which will be established the encrypted IP tunnel from that particular PC across that particular service provider shared network, right? So from their corporate network, and this particular NAS which will be initiated that particular virtual private network, which will be the tunnel is initiated from that particular NAS, that is network access server, right? And on that part, this particular communication will be happen, right? So it will be used mainly in the corporate internet, if you see, right? They have their own VPN, and from using some dial-up and all the transport technologies, whatever we have studied, transport WAN technologies they are going to use, and from that they can access all this VPN part, right? So this is nothing but the access VPN. And then the intranet VPN, if you talk about, then whatever the intranet VPN link remote offices, right, by extending some corporate network across the shared infrastructure, right? So this particular intranet VPN services, right, which will be extending the basic remote access VPN, right, to other different corporate offices across the internet also, right? So you can intranet VPN is nothing but for your if you are having some of the more corporate offices or branches, then you can use that particular internet VPN also across the all the branches, right? So it will be extend the support for your internet VPN over the different corporate offices, right? So for that also, this particular internet VPN we are going to use. Then the external VPN, if you see, it will be we can use again extend the connectivity to business partners, suppliers, or customer, right, across the internet over the service providers network, right? So it will be again we are going to expand or extend our expansion, right? So from access VPN to I am going to use for internet, and from internet to I am also giving external VPN to my customer and to my partners or to my suppliers or whoever in a team, right? So through that I am going to provide here those VPN applications, right? So these are some VPN with respect to the application, right? Then we will see how VPN connectivity will be take place, right? So there are through overlays VPN we can have a connectivity to private dial-up network, as I discussed. We can call it as VPDN network, and some other one is your peer-to-peer VPN also, right? So if you see so if you use this particular overlays VPN, right, so in this that particular infrastructure will provide point-to-point links in between the customer sites, right? So overlay VPN will be implemented in number of technologies, right? For example, if you see ISDN, we have seen SONET, we have seen DSH, then frame relay, ATM, right? So you can use any kind of the transport technology for implementation of this particular overlays VPN, VPNs, right? And if you talking about this particular virtual private network, right? So if you see in this particular diagram, right, so here we have uses some overlays VPN, right? So the router which we are seeing as the left hand side here, right, so this is the enterprise edge module, for example, right? And through these which having only one connection to the service provider, right? So here if you see, and with having two virtual circuits provisioning, right, the virtual circuit 1 and the virtual circuit 1 and the virtual circuit 2, right, which will be provide connectivity to this particular to this particular branch offices, if you see, right? And branch office router which we are seeing on the bottom right side, right? So this is nothing but one of the we can call it as an example for this enterprise architecture which uses this particular overlay VPN, right? Which will be extending the enterprise IP network access over the shared WAN, right? So we call it as an VPN. Then if you see this particular VPDN, right, which will be uses for enabling the enterprise to configure secure network, right? That be and obviously on the internet service provider for connectivity with VPDN, right? And customer can be use this particular service with the help of some dial-in connection or dialing or some using some private connections over there, right? With the help of this particular this, right? So if you see in the figure, right, so this particular internet service provider, right, that is nothing but your ISP. If you see terminates the dial-up connection at here in this particular we can call it LAC, that is L2TP access LAC, that is L2 TP access concentrator, if you see, right? And from that it will dynamically establish the tunnels to this particular remote access server, right? And from that it will be using this particular VPDN, right? So this will some of the architecture of VPDN for remote access, right? Then we will have some third one is your the peer-to-peer, right? So if you see in the peer-to-peer VPN, it will be provide actively participation in customer routing, alright? So traditional peer-to-peer, if you see, it will be implemented in packet filters, right? So so for that the dedicated per customer PE routers will be there, right? And it will be require some high maintenance cost, because whenever the packet filter approach or you are going to use, right? So if you are going to use dedicatedly per customer router approach, right, then it will be cost you more, right? And it will be happen in this particular peer-to-peer, right? So you can use any kind of the transport technologies of WAN, that is MPLS or anything, right, in order to establish the connection for that particular peer-to-peer VPN, right? And if you talk about the benefits of VPN, right, what exactly the benefits of VPN is having the flexibility, if you see that. So VPN offers you the flexibility, because whenever the side to side or any remote access connection if you are going to use, right, so it will be helpful for very quickly set up, right? There will be existing infrastructure in that also you can use that particular for accessing all the remote users. You can use this particular VPN, so it is very flexible. It is in scalability, so it is also a scalable one, right? So you can extend the support in this particular VPN, right? So remote to external users also you can add it into your VPN, right? So and the third one is the lower network communication cost, right? So obviously the lower cost is the primary reason for any kind of the emerging connectivity, if you see, right? So in this particular VPN connection also, if you are using the dial-up, if you are using some dedicated bandwidth infrastructure, and if you are taking some service provider cost, if you see, right? For VPN is very much costly, very much low cost than all these things, right? So customer can be reuse all the existing links can be used and take the advantage of this particular packet multiplexing and all that things, right? So that is one of the benefits for this particular VPN, right? Then we will see the backup strategies of WAN, right? So if you see in backup, okay, so this part we will cover in our next section, session, right? So we will stop today and we will continue from this particular WAN backup strategy in our next session, right? So we will stop today. There will be no test today. Okay, thank you for joining.